The HSC Mathematics course relies heavily on algebra. The majority of the questions that you'll face in the HSC will require you to do some form of algebraic manipulation. It is very easy to make a mistake when you're rushing through a challenging problem, particularly with your algebra laws, such as forgetting that you can only add and subtract like terms, or forgetting a negative term when you're expanding and factorising, and this will often completely affect your result. Another common mistake that's made is forgetting your fraction laws, such as finding common denominators and generally finding the lowest common denominator so that you don't have to simplify some gross looking expression. Cancelling things that can't be cancelled because they haven't first found the highest common factor between the numerator and the denominator. Or forgetting how to divide fractions, which simply means multiply by the reciprocal. Another common mistake that happens when you're rushing through questions is just forgetting your basic order of operations: brackets over multiplication, division, and then addition and subtraction. It counts for everything, including your algebraic questions. In this lesson, we'll have a look at two reasonably involved algebraic questions and make sure that we are covering these 3 points in everything that we're doing. Our first question is from the 2014 HSC, question 26C, so it's towards the end of the paper. It appears to be a reasonably complex equation solving question, but really this question was in there to give you a breather towards the end of that paper. So remember that this question requires us to find the solution for x, or the x value that makes the left-hand side equal the right-hand side. So we're looking to use inverse operations to undo everything that has been done to build this equation in the first place, until all we're left with is x equals a value. It's generally easiest to start with the left-hand side first. So we'll have a look at the last thing that we would have done to build this equation. So we would have subtracted 4 on the left-hand side as our last step. And so therefore it will be the first thing I need to undo. Remember that we're using inverse operations to undo what's been done. So the inverse of subtraction is to add. So we're going to add 4 to both sides. This is where you must remember your like terms. You can only add and subtract terms that are exactly alike. So if we're adding 4 to both sides of this equation to keep it balanced, then on the right hand side I can only add that 4 to the 5. This leaves us with 5x plus 1 all over 3 on the left hand side. Adding the 5 and the 4 together gives us 9 minus 7x on the right hand side. This is where students will often make their mistake. The next thing they'll go to remove is the denominator of 3, which is the correct step, and they know that they need to multiply both sides by 3. However, the common mistake that is made is that they forget that they are multiplying every single term in this equation by 3. So by multiplying the whole left-hand side by 3, it removes the denominator and leaves us with 5x plus 1. But on the right-hand side, we must multiply both terms by 3. So 9 times 3 gives us 27, and negative 7x times 3 gives us negative 21x. From here, the equation becomes reasonably simple to solve, and most students are able to do it from this point. We need to move the negative 21x as it's an x term sitting on the wrong side. Again, we'll use the inverse operation, so we'll add 21x to both sides to keep our equation balanced. And again, you must remember to use your like terms here. You can only add the x values together. So 5x plus 21x gives me 26x plus 1 on the left-hand side. and 27 left over on the right-hand side. This now becomes a two-step equation, so we'll next remove the positive 1 from the left-hand side by subtracting it from both sides, leaving us with 26x is equal to 26. And so finally, by dividing both sides by 26, we're left with our solution, x is equal to 1. This second question is a challenge question and something that lots of students do struggle with. Here we're not solving an equation but simply simplifying the expression in front of us as much as we can. Firstly, we'll need to find a common denominator so that we can subtract our fractions, and we're looking for the lowest common denominator so that we don't have to further simplify our question later on. We must also remember our like terms when we're manipulating the numerators. And the third trick is to factorise our expression as much as we can so that we can find the highest common factor between the numerator and the denominator to allow us to cancel between them. This will also help me identify my lowest common denominator, as I won't be doubling up on factors if I know what all of them are. So starting on the left-hand side of our expression, the numerator of the first fraction has a singular x term that can't be factorised. But the denominator is the difference of two squares. And so we know that that is going to factorise into x minus 1, x plus 1. In the second fraction, students often try to factorise the x squared plus 1 term. There are no common factors between these two terms though, and this expression cannot be factorised. However, we know that the bottom cubic can factorise to x minus 1, x squared plus x plus 1. Now that we've factorised, we'll be able to see the common factors between the numerators and the denominators and be able to form the lowest common denominator possible. So upon inspection, both fractions already contain this x minus 1 term. It will be a part of our new denominator, but it's not necessary to include it in the numerators of either fraction, as both fractions already contain the expression. We also need to include this x plus 1 term, but the second fraction is missing it, and so we need to make sure that we multiply the numerator of the second fraction by that x plus 1 term to keep it balanced. Similarly, we also need to add this trinomial term to our denominator, but the first fraction is missing it. And so to keep it balanced, we must make sure that we multiply our numerator by it. And this will give us the entire numerator we need to add on the top. Because we are also subtracting here, I am going to make sure that I keep that second section of my numerator in brackets to remind myself that I must expand that negative throughout the whole lot. This is one of the most common mistakes that students will make, and they forget that this negative term is going to affect the whole numerator of that second fraction. So by keeping it in brackets, I will ensure that I don't forget to carry it through. The last part of this question is now just using my algebra skills to manipulate the numerator and find all of my like terms. So by expanding, we get x cubed plus x squared plus x in the first section. And before I carry that negative through, I'm going to expand the section inside the red brackets first, keeping those red brackets there to remind myself that everything inside it will be taken away. So expanding this binomial product, we get x cubed plus x squared plus x plus 1. I'm not going to expand the denominator at the moment, as it will allow me to cancel any common factors I may end up with if I keep it in its factorized form. It's not a requirement that you must expand it to simplify the expression anyway, and so you're just creating further work for yourself if you do. Now having a look at our numerators and noticing that we are subtracting that whole red section, lots of our terms cancel here. We have x cubed minus x cubed, so the x cubed terms have gone. The same happens with the x squareds, x squared minus x squared. We have x minus x, and so all we are left with is a negative 1 on the top of our fraction, which means although there are no more factors that we can cancel with this denominator, our most simple expression is written in its factorized format with a negative 1 on the top. As I mentioned, it's not a requirement from here to expand the denominator. It won't pick you up any further marks, and so you're just wasting precious time in your exam.